Hello all, welcome to Java Technopreps. In the previous session we have discussed basic the collection types which are list and maps. So we are able to understand that list is a single dimensional array and maps are two-dimensional array, right? So since basically it's unique, right? So in the maps basically there is a key and value. The key is holding the identifier and the value is referring to an object or a collection objects. So in this example we have department ID as a key and value as the employees list. Okay, so in such scenario we go for maps, whereas in list it's a single dimensional. You can store anything from primitives to objects. Primitives are typecasted to objects internally. Alright, so let's continue our discussion with on maps. Right, so what is map? Map is an interface. Basically, what are the characteristics of maps so that the extending classes can have that behavior? So map, an object that maps key to value, which we have already discussed, and then duplicate keys are not allowed. So duplicate keys are not allowed in maps. So what happens when you add a duplicate key? Probably it will be overridden. So there will be only one key. There will not be two keys with the same value. All right, so let's test it. Okay, so here we have, say for example, this is the enp store hm, and here I will try to add a. So here you can see that key is same. So when you run it, the number of the I have printed the size. So there is only one size, one element, one object inside each of the collection. So the duplicates are not entertained, right? So next is that the three collection views. So what are these three collection views? Let me check it out here. So take any example. So here we have the collection. This is one view. This itself is a collection, and second collection is that basically the keys. Okay, so this is one kind of collection view. Okay, so what it is returning? It is returning set of strings. Okay, as keys. So this is one collection view. And what is the next collection view? And the next collection view is of values. Okay, so the values which is written by the collection. uh, so it is returning collection of employees. Since here I'm adding value as employee, so it is returning me the collection of employees. All right, when I say values, it will return all the values that are available in this collection. So these are the three types of views that we are discussing here. So basically map is an interface. So these are all the implementing classes of the map interface: the hash map, hash table, concurrent hash map, linked hash map, tree map, weak hash maps. Why are there so many hash maps? Basically each one has its own behavior and algorithm implementation internally. So because there are multiple requirements, so each one try to solve the problem of the each of the requirement, right? So let's go one by one. Let's take hash table. uh, Basically hash table, uh, any null object can be used as a key or its value, right? So basically what does it mean? It means that you cannot add any null value in a hash table. Okay, let's check it out. So let's remove this one. So we are talking about hash table. So this is the hash table. Let me add a null value here. What happens when I give a null value? So it throws an exception, right? It's null pointer exception. So it does not accept any null as keys. Whereas in hash map, you can add null value. Okay, if I add null value over here, it will not throw any exception. It's done. Basically, it gives me two elements. That null is also one element and a is second. So there are two entries in hash map. Even though we provide null, it accepts it. That's the reason why the hash table does not entertain null values. Objects use keys shall implement equals and hash code. Why is it required? Because internally it is generates a hashing algorithm which generates the hash code. So if we internally the each object has its own hash code, right? So if you do not implement it, take for example the employee class, right here. Basically it does not have any hash. So if I try to print an hash code, okay, hash code, it gives me some internally generated numeric. Okay, so this is the internally generated hash code. Since we have not Performance. Basically, performance is measured by how the algorithm performs when we are adding the elements into the collection object and performing CRUD operations like removing, updating, adding. So what would be the time consumption? So this is the time consumed is the performance here. So it depends on the initial capacity. So what is initial capacity? So when you are defining a hash map or hash table, right? So you are not mentioning any size. So default it has its own capacity, each collection object. So for now, basically the collection the default value is 10. So when you create a map, hash map, basically internally it allocates space for 10 elements. Okay. So you can also define your own size here, right? So what is the when you have to define its own when you have to define the size of the hash map instead of using the default value. Okay, so what happens internally? So you need to understand that. So for example, the default value is 10. So in case I am adding 10 elements into the hash map, okay, so what happens? Basically the size has to resize, right? So at what point will it resize? How many times will it resize? What will do during the resizing internally? So all these questions comes into the picture when you are evaluating the performance. So for example, you already know that you have 1000 elements and to add into the hash map. So providing the 1000 as the initialized value will give you high performance because each time it does not have to resize and perform the rehashing on the collections. Okay, so the initial size is very important factor to improve the performance. And next is the load factor. What is the load factor? So load factor is that, like say for example, you have 1000 elements and you have not defined any value over here, right? So initially default by default it takes 10. So at what point will it resize? It will not wait till 10th element is added into the collection. It must perform the resizing before that. So that is the point where you define the load factor. Okay, so for example, you define 0.7 right as the load factor. Basically at the when once you add the seventh element, the resizing will occur impact. So at the 70% of the elements were added. Say if you have given size 100 and you have given the load factor of 0.7. So once you are completed adding the 70 elements, then the resizing will occur. So that is the load factor. So that will define like at what point you should define the load factor so that the performance will improve. And another thing is that basically uh, it is a legacy class. Hash table is a legacy class which is defined before Java 1.2. In Java 1.2, Java collection framework came into picture. So hash table is brought into its umbrella, right? So basically it has to implement the map interface for that, and then you implement all the methods which are common across the hash maps, right? So the next point is hash table is synchronized. So what does you mean by synchronized? So if there are multiple threads that are accessing the collection, so it can access in one by one, right? So once the one thread is acquired the lock, so the other threads has to wait till the lock is the previous thread is completed processing, then only the lock is given to the next priority thread. Okay, so that is synchronized. So what is the impact? It will impact the performance because multiple threads are not able to access at the same point of time, right? Since it is synchronized, in that case, basically if you think that there is no need of updating the data during the iteration process, then you can go for hash map. Since there is no operation, there will not be dirty rates, right? So in case if you feel that your application requires to update the collection, then go for concurrent hash map. Why? Because concurrent hash map has internally developed an algorithm which can handle synchronized processing in a performance better manner. So it's more efficient way. Why? It has its own implementation to slice the collection into 16 slices, and then so that 16 threads at a time can access the blocks, right? So that is the reason why you should not use hash table and you should choose between hash map and concurrent hash map. Let's discuss about them in the next session. Till then, bye. Thanks for watching.